Chapter 2. Is matter around us pure? Pure substances and mixtures. When you buy foodstuffs like milk, ghee and sugar from the market, you would have noticed the word pure written on their packets. What does pure mean in these cases? It means having no adulteration. But are they actually pure? In science, when we say that something is pure, it means that the substance is made up of same particles throughout. Milk is made of water, fat and proteins. Hence, it is a mixture and not pure. On the other hand, sugar is made of sugar particles only. Hence, it is a pure substance. Thus, matter around us comprises of two types of substances, pure substances and mixtures.
Most of the substances around us exist as mixtures of two or more substances. Wood is made up of cellulose and lignin. Soil is made up of rock, sand, clay, humus, etc. Milk is made up of water, fat, proteins, etc. Salt solution is made up of salt and water. There are also some substances which exist as single substances. They are called pure substances. A pure substance consists of only one type of atoms or molecules. For example, nitrogen is made up of atoms of nitrogen. Sodium is made up of atoms of sodium. Common salt or sodium chloride is made up of only molecules of sodium chloride. On the basis of their chemical composition, pure substances are divided into elements and compounds. Here, nitrogen and sodium are elements, but common salt is a compound. Sugar and mercury are pure substances. What does sugar and mercury contain? Sugar molecules contains atoms of carbon, hydrogen and oxygen. Mercury is made up of only atoms of mercury. So, sugar is a compound, but mercury is an element. Mixtures. A mixture contains more than one substance mixed in any proportion. Milk, soil, lemon juice are examples of mixtures. Let us perform an activity to understand more about mixtures. Take a dish. Put some iron fillings and sulfur powder into the dish. Mix them properly. Hold a magnet over this mixture. What do you observe? The iron fillings cling to the magnet while sulfur powder remains in the dish. The properties of iron and sulfur are retained in the mixture. We used a simple physical process like holding a magnet to separate the iron from the mixture. Now, we can summarize the properties of a mixture. In a mixture, two or more elements or compounds are not chemically combined together. The constituents of a mixture retain their original properties. The constituents of a mixture can be separated by using a physical process like hand picking, filtration, holding a magnet, etc.
Here are a few more examples of mixtures. Alloys.
Alloys are prepared by fusing together two or more metals or a metal and a non-metal. The components of an alloy cannot be separated by using physical methods. But still, alloys are considered as mixtures because the constituents can have variable composition. They show the properties of its constituents. Brass is considered a mixture because it shows the properties of its constituents, copper and zinc, and the constituents can have variable composition. The amount of zinc in brass is approximately 30%, and that of copper is approximately 70%. Alloying is done to improve the properties of a metal. Stainless steel is an alloy of iron, carbon, chromium, and nickel. Carbon gives hardness to the mixture, while chromium and nickel give a silvery look to the mixture.
Air.
Air is a mixture of various gases like oxygen, nitrogen, carbon dioxide, argon, water vapor, etc. Air shows the properties of all the gases present in it. For example, oxygen supports combustion and air also supports combustion. If air is prepared by mixing the required proportions of oxygen, nitrogen, carbon dioxide, water vapor, etc., no chemical reaction takes place. Air has a variable composition. For example, the air in an industrial area will have a higher percentage of carbon dioxide and other polluting gases compared to the air in the countryside. Types of mixtures. Activity. Let us perform an activity to know about the different types of mixtures. Let us make 3 groups of 2 students each. Name them as Group A, Group B, and Group C. Each of these groups has to perform a small experiment. We shall give half a spoon of potassium permanganate and 100 milliliters of water to Group A. Half a teaspoon of potassium permanganate and half a teaspoon of salt to Group B. And half a teaspoon of soil and 100 milliliters of water to Group C. Now instruct all the groups to mix the given substances using a glass rod. We now have 3 mixtures. Let us now record the observations of each of these groups. Have all the 3 groups obtained uniform mixtures? Which group has obtained a uniform mixture? Group A has a mixture of potassium permanganate and water. This is a uniform mixture. We can see that the particles of potassium permanganate dissolve uniformly in water to form a purple-colored solution. Which group has obtained a non-uniform mixture? Group B has a mixture of potassium permanganate and salt. Group C has a mixture of soil and water. In both these mixtures, the constituents do not mix uniformly with each other. Hence, we can say that Group B and Group C have obtained non-uniform mixtures. Mixtures are of two types: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures. Mixtures in which the substances are completely mixed together uniformly and cannot be distinguished from each other are called homogeneous mixtures. A homogeneous mixture has uniform composition throughout its mass. All homogeneous mixtures are solutions. A sugar solution is a homogeneous mixture because all the parts of the mixture have the same sugar-water composition and have equal sweetness. Potassium permanganate solution, salt solution, seawater, soft drinks, alcohol and water mixture, air and alloys are examples of homogeneous mixtures. Heterogeneous mixtures. Mixtures in which the substances remain separate and one substance is spread throughout the other substance as small particles or droplets are called heterogeneous mixtures. Heterogeneous mixtures does not have a uniform composition throughout its mass. A mixture of sand and water, chalk powder and water, oil and water, milk, ink, soil, paint are all examples of heterogeneous mixtures. Heterogeneous mixtures.
Let us perform an activity to understand more about different types of homogeneous and heterogeneous mixtures. Make 3 groups of 2 students each. Name them as Group L, Group P, and Group D. Distribute different samples to each group. Give half a teaspoon of potassium permanganate to Group L. Give some chalk powder or some wheat powder to Group P and a few drops of ink to Group D. Instruct all the groups to add the given sample in beakers containing water and stir them properly using glass rod. Now, direct a beam of light from a torch through the beakers containing the mixtures. Is the path of beam of light visible through all the beakers? The beam of light is only visible through the beaker containing drops of ink and water and the beaker containing a mixture of chalk powder and water. Leave the mixtures undisturbed for a few minutes. Arrange 3 filtration assemblies using conical flasks and ordinary filter papers. Now, filter each of these mixtures through the filter papers. Is there any residue on the filter papers? Group L and D did not get any residue on the filter paper. Group P got a residue of chalk or wheat on the filter paper. The mixture with Group L is called a solution. The mixture with Group P is a suspension, and that with Group D is a colloidal solution. Solutions.
A solution is a homogeneous mixture of 2 or more substances. Such a mixture has uniform composition throughout its mass. A salt solution, sugar solution, copper sulfate solution, lemonade, a sweetened drink made from lemon juice or lemon flavor, are examples of solutions. Solutions can be of various types. Solution of a solid in a solid. Alloys are solutions of solids in solids. Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Solution of a solid in a liquid. Salt and sugar solutions are examples of this type of solution. Solution of a liquid in a liquid. A solution of alcohol in water, a solution of acetic acid in water are both examples of this type of solution. Solution of a gas in a liquid. Soda water is a solution of carbon dioxide in water. Oxygen or any gas dissolved in water is a gas in liquid type of solution. Solution of gas in gas. Air is a mixture of gases like oxygen, nitrogen, carbon dioxide, water vapor, etc. Solution of gas in solid. Rubber and sponge are examples of a gas in solid type of solution. Solution of a liquid in a solid.
Amalgam is a solution of mercury with any metal, for example, gold.
What are the properties of a solution? The particles of a solution cannot be seen even through a microscope. The particles can pass through the filter paper. So, a solution cannot be separated by filtration. Solutions are very stable, that is, the particles in a solution do not separate out on keeping. A solution cannot scatter light as the particles of a solution are so small that they cannot reflect light. A solution is made up of two components, a solute and a solvent. The substance which is dissolved in a liquid to make a solution is called as solute, and the liquid in which the solute is dissolved is known as solvent. Usually, the solute is the substance that is present in lesser amounts in a solution, and the solvent is the substance present in larger amounts in a solution. In a solution of potassium permanganate, the solute is potassium permanganate and the solvent is water.
Concentration of a solution.
The properties of a solution depend upon the nature of the solute and the solvent, and also upon the proportion of dissolved solute. The quantity of dissolved solute per unit volume of solution is called concentration of the solution. When a large quantity of a solute is in dissolved state of a solution, the solution is said to be concentrated. When the quantity of a solute dissolved in the same amount of solution is small, the solution is said to be dilute.
The concentration of the solution is the amount of solute present in a given amount of the solution. There are two methods of expressing the concentration of the solution. If the solution is prepared by dissolving a solid solute in a liquid, then we consider the mass percentage of the solute for determining the concentration of the solution. Here, the concentration of the solution is defined as the mass of the solute in grams present in 100 grams of the solution. If 10 grams of sodium chloride is present in 100 grams of the solution, then the mass by mass percentage of the solution can be calculated by using the formula concentration of solution equals mass of solute divided by mass of solution multiplied by 100. Here, mass of solute equals 10 grams, mass of solution equals 100 grams. Therefore, concentration of solution is 10 divided by 100 multiplied by 100. That is equal to 10% by mass. If the solution is prepared by dissolving a liquid solute in a liquid, then we consider the volume percentage of the solute for determining the concentration of the solution. Here, the concentration of the solution is defined as the volume of the solute in milliliters present in 100 milliliters of the solution. Then the mass by volume percentage of the solution can be calculated using the formula concentration of solution equals volume of solute divided by volume of solution multiplied by 100. If 50 ml of alcohol is mixed with 150 ml of water, here volume of solute equals 50 ml. Volume of water equals 150 ml. So, the total volume of solution equals volume of solute plus volume of solvent equals 50 plus 150 equals 200 ml. Therefore, concentration of the solution equals 50 divided by 200 multiplied by 100. That is equal to 25% by volume.
Suspensions. A suspension is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving in it. Chalk powder in water, muddy water, wheat flour in water, sand in water are all examples of a suspension. What are the properties of a suspension? The particles of a suspension can be seen easily. The particles cannot pass through a filter paper. So, a suspension can be separated by filtration. Suspensions are unstable. The particles of a suspension settle at the base after some time. A suspension can scatter a beam of light passing through it as the particles are quite large. Colloids. Colloids are a type of solution in which the size of the solute particles is intermediate between solutions and suspensions. When observed through a high-powered microscope, the particles in a colloid appear to be floating over the surface of the liquid. This shows that colloids are heterogeneous in nature, though they appear to be homogeneous. Milk, ink, blood are examples of colloids. What are the properties of a colloid? The particles of a colloid can pass through a filter paper. So, a colloid cannot be separated by filtration. Colloids are quite stable. The particles of a colloid do not separate out on keeping. A colloid can scatter a beam of light passing through it because the particles of a colloid are fairly big in size. The solute particles of a colloid are called the disperse phase and the solvent is called the dispersion medium. The dispersed phase and the dispersion medium both could be in the solid, liquid, or gaseous state. Let us study a few examples. Milk is a colloid where droplets of milk are dispersed in water. Both the dispersed phase and the dispersion medium are in the liquid state. In smoke, carbon particles or soot are dispersed in the air. Here, the dispersed phase is in the solid state and dispersion medium is in the gaseous state. Ink is a colloid where solid particles of ink are dispersed in water. The dispersed phase is in the solid state, while the dispersion medium is in the liquid state. Why does a colloid scatter light? If a beam of light is put on a colloidal solution like ink in a dark room, the path of the beam of light is illuminated and it becomes visible from the other side. The particle size of colloids is large enough to scatter light. This scattered light enters our eyes and we are able to see the path of the light beam. This scattering of light by colloidal particles is known as the Tyndall effect. It is named after the scientist Tyndall. You may have observed dust particles in the air when sunlight comes in through a window or comes through holes in clouds. Dust particles in air are also observed when headlight beams are visible on foggy nights. These are actually colloid particles which scatter light.
Separation techniques. Most substances in nature are not chemically pure. They are mixtures. Separation of different components of a mixture helps to study each component and put them to other uses. Components of heterogeneous mixtures can be separated by simple physical methods like hand-picking, sieving, filtration, etc. Components of a homogeneous mixture require some special techniques. Let us see a few examples. Separating the components of ink. Let us perform an activity to separate the blue dye from blue ink. Take a beaker half filled with water. Place a watch glass over the beaker. Add a few drops of ink on the watch glass. Now, heat the beaker for some time. What do you observe? You will observe that the water from the ink is gradually evaporating. When all the water has evaporated, stop heating the beaker. There is some colored material left in the watch glass. This colored material is the solid dye obtained after all the water from the ink has evaporated. This process of separation is called evaporation. This method can be used to separate a volatile solvent from non-volatile solute. From this activity, it is clear that evaporation is used to separate mixtures. Ink is a mixture and not a pure substance. Separating the components of milk. Let us perform an activity to separate cream from milk. Take some full cream milk in a test tube. Centrifuge it using a centrifuge machine. What do you observe? Milk gets separated into cream and skimmed milk. Cream, being lighter, floats over the skimmed milk. This method of separation is called Centrifugation. Centrifugation is a method in which a mixture is rotated at high speed in a centrifuge. Due to the high speed, suspended particles present in the mixture are separated from the liquid. The process of centrifugation is used in washing machines to squeeze out water from wet clothes. Centrifugation can also be used in diagnostic laboratories for blood tests. Blood is a mixture of blood cells and plasma. Blood can be separated into blood cells and plasma by the process of centrifugation. Clay particles suspended in water can be easily separated by the method of centrifugation. The clay particles, being heavy, settle at the bottom and the clear water remains at the top. Separation of two immiscible liquids.
Liquids which do not mix with each other are called immiscible liquids. A mixture of kerosene and water is immiscible. Arrange the separating funnel on the stand. Fill the mixture of water and kerosene in the funnel. At this time, the cork is kept closed. The layer of kerosene is seen because water and kerosene are immiscible with each other. Place a beaker under the separating funnel. Now, open the cork in such a way that water from the funnel comes into the beaker very slowly. Close the cork when water flows out completely from the separating funnel. Only kerosene remains in the funnel. Now place another beaker under the funnel and open the cork. As a result, kerosene from the funnel will be collected in the beaker slowly. Thus, the liquid substances which do not mix with each other can be separated by using a separating funnel.
A separating funnel can be used to separate immiscible liquids. The separation of two immiscible liquids depends upon the densities of the two liquids. The liquid having higher density forms the lower layer, while the liquid with less density forms the upper layer. A separating funnel can be used to separate a mixture of petrol and water or a mixture of oil and water. Solvents like carbon disulfide, benzene, ether, and chloroform are immiscible in water. A separating funnel can be used to separate mixtures of carbon disulfide and water, benzene and water, ether and water, and chloroform and water. The principle of separation of substances based on their densities is useful even in industries. During the extraction of iron in the blast furnace, the molten iron forms the lower layer and collects at the bottom of the blast furnace, while the waste material, that is slag, obtained during the extraction being lighter, forms a separate layer on the top of this molten iron. Separation by sublimation. We know that the process due to which a solid directly changes to gaseous or vapor state and on cooling directly changes back to solid state without changing into liquid state is called sublimation. So, this method can be used to separate mixtures that contain a volatile sublimable component from a non-volatile impurity. Let us understand this with the help of an activity.
How would you separate the mixture of sand and iodine crystals? Take a mixture of sand and iodine crystals in an evaporating dish. Plug the open end of the funnel with cotton. Place an inverted funnel over the dish. Now, heat the dish. There are violet vapors visible. Stop heating the evaporating dish and allow it to cool. There is a violet deposit on the inner wall of the glass funnel near the base of the stem. With the help of a spatula, scrape out this into a watch glass. These violet crystals are iodine crystals. Observe the evaporating dish. What remains in the evaporating dish is sand. In this way, sand and iodine can be separated.
Separation by chromatography. Let us perform an activity to understand chromatography. Take about 10 ml of 50% alcohol, that is, the eluent in a glass jar. Cover it with its lid. Now cut a strip of chromatography paper. Draw a line by pencil parallel to one edge of the paper about 2 centimeters above the edge. This is the base line. Draw another line at a distance of 10 centimeters from the base line. This is the solvent front. Using a capillary, place a drop of the mixture of inks at the center of the base line. Allow it to dry. Successively put 2 to 3 drops at the same point and allow the drops to dry. Suspend the paper strip in the jar such that the lower end of the strip carrying the spot just dips in the solvent. Now cover the jar. When the solvent or the eluent reaches the upper line or the solvent front, remove the paper and allow it to dry. Two spots, that is, a red spot and a blue spot, are seen on the paper. This process of separation of mixtures is called chromatography. This method is used to separate those substances that dissolve in the same solvent. Generally, different components have different solubilities. The component which is more soluble rises higher than the component which is less soluble. In this way, the different components get separated. With this technique, we can separate various color components of a dye, pigments from natural colors, drugs from blood, etc. Distillation. We can obtain salt from salt-water mixture by evaporation. Water cannot be recovered during evaporation but is lost in the air. In order to recover both salt as well as water from salt-water mixture, the process of distillation is used. Distillation is a process in which a liquid is heated up first to its boiling point, and then its vapor is cooled to obtain the liquid again. This method is used when both the components of a mixture need to be recovered. In this process, the more volatile component of a mixture evaporates. The vapors are collected and cooled to obtain the component again. The other component is not affected. If the mixture consists of two liquids, then the more volatile liquid is obtained first, and then the less volatile liquid is obtained. Let us perform another activity to understand the process of distillation. Take a solution of acetone in water in a round bottom flask. Fit the flask with two-holed rubber stopper using a clamp and an iron stand. Fit a thermometer in one hole and a bent glass tube in the other hole of the rubber stopper. Take two pieces of a rubber tube. Connect the free end of the glass tube to a condenser with the help of one rubber tube. Fit the other piece of rubber tube to the other end of the condenser. Put this end into a beaker. A condenser has two glass tubes with different diameters. The glass tube with the smaller diameter is placed into the tube with a bigger diameter. There are two openings at each end of the outer glass tube, called the inlet and the outlet. These openings allow the circulation of cold water around the inner tube. Place the round bottom flask on a wire gauze placed on tripod stand. Now heat the round bottom flask with a burner. When the round bottom flask is heated, acetone present in the solution vaporizes and reaches to the upper part of the flask. This happens because boiling point of acetone is 56 degrees Celsius, which is less than water, that is 100 degrees Celsius. The vapors of acetone pass through the condenser, get cooled, and collect in the beaker kept at the other end of the condenser. Water remains behind in the round bottom flask. In this way, both the liquids can be separated. However, a complete separation of two miscible liquids cannot be done using simple distillation. For the complete separation of two or more miscible liquids, the process of fractional distillation can be used. Fractional distillation. Fractional distillation process is used to separate a mixture of two or more miscible liquids for which the difference in the boiling points is less than 25 Kelvin. In other words, fractional distillation is a suitable method for separation of a mixture containing miscible liquids. The apparatus used for fractional distillation is similar to the distillation apparatus, except that a fractionating column is fitted between the distillation flask and the condenser. A fractionating column is a tube packed with glass beads. The glass beads provide a surface for the vapors to cool and condense rapidly. In simple terms, a fractionating column can be regarded as an arrangement for providing different temperature zones inside it during distillation. The highest temperature observed inside the fractionating column during distillation process is at bottom of the column, and lowest temperature is observed at the top of the column. Fractional distillation is used to separate mixtures of alcohol and water and also mixtures of three miscible liquids. Crude oil can be separated into its fractions by fractional distillation. Fractional distillation can also be used to separate a mixture of gases. Separation of gases. Air is a homogeneous mixture of different gases like nitrogen, oxygen, carbon dioxide, argon, helium, neon, krypton, etc. Various gases of air are separated by fractional distillation based on the fact that different gases have different boiling points. air can be separated into its components by following steps. Air is first compressed to a high pressure and then cooled. This process is repeated again and again to make air more and more cool. Ultimately, the air gets so cooled that liquid air is obtained. The liquid air is fed into the tall fractional distillation column from the bottom and warmed up slowly. Liquid nitrogen present in air has the lowest boiling point of minus 196 degrees Celsius. On warming, liquid nitrogen boils off first to form nitrogen gas, which is collected at the top part of the fractionating column. Liquid argon has a slightly higher boiling point of minus 186 degrees Celsius, so it boils off next and is collected in the middle of the fractionating column. Liquid oxygen has a still higher boiling point of minus 183 degrees Celsius, so it boils off last and is collected at the bottom of the fractionating column, obtaining pure substances from impure ones.
Solid substances can be obtained from their solution by the process of evaporation or crystallization. For example, copper sulfate can be obtained from its solution in water by evaporation or crystallization.
Crystallization is a method to purify crystals. The process of forming crystals is called crystallization. Crystals are the purest form of any solid substance. Let us perform an activity to obtain pure copper sulfate crystals. Take solution of the impure copper sulfate and evaporate it till it becomes saturated. Filter the hot solution to remove impurities. Cool the solution to room temperature. Pure crystals of copper sulfate crystallize from the solution. The process of crystallization can be used to obtain pure salt from an impure salt sample obtained from seawater. Crystals of alum also can be obtained from an impure sample of alum.
Physical and chemical changes. We observe many changes around us. When ice cream is kept outside the freezer, it melts after some time. When you put few drops of lemon juice in boiling milk, it curdles. Let us name these two changes as C1 and C2. When we keep the melted ice cream back into the freezer, it again solidifies. That is, the change is temporary, reversible, and ice cream does not change to a new substance. Also, its composition remains the same. This type of change is called as a physical change. In change C2, milk curdles to form a new substance, cottage cheese or paneer as it is commonly called. We cannot get back the original substance, milk. That is, it is a permanent and irreversible change, and hence it is called as a chemical change.
Pure substances,
Elements. Antoine Lavoisier, a French chemist, defined an element as the basic form of matter that cannot be broken down into simpler substances by chemical reactions. Examples of elements are copper, iron, carbon, hydrogen, etc. Today, there are 119 elements known to us, out of which about 92 elements are naturally occurring. An element can be represented by using a symbol. For example, the symbol of hydrogen is H. A molecule of hydrogen consists of 2 hydrogen atoms. Hence, the molecular formula of hydrogen is written as H2. Copper is an element. It is made up of only copper atoms and is represented by the symbol Cu. Elements are classified as metals, nonmetals, and metalloids. Nonmetals. Nonmetals are in the solid, liquid, or gaseous state. They are brittle. Non-metals are not lustrous, sonorous, malleable, or ductile. They are poor conductors of heat and electricity. Examples of non-metals are oxygen, hydrogen, nitrogen, carbon. Metalloids. There are some elements that have properties similar to metals as well as non-metals. They are called metalloids. Examples of metalloids are silicon, boron, and germanium. Compounds. A compound is a substance composed of 2 or more elements chemically combined with one another in a fixed proportion. It is represented by a molecular formula. Water, carbon dioxide, chalk, and washing soda are all compounds. A compound can be divided into simpler substances by a chemical process. The physical and chemical properties of a compound are completely different from those of its constituents. Why is water a compound? Water is composed of hydrogen and oxygen. They are chemically combined with each other in the ratio of 2:1. Its molecular formula is H2O. The properties of water are different from those of hydrogen and oxygen. Hydrogen is combustible, while oxygen supports burning. But water is neither combustible nor does it support burning. In fact, if water is poured on a fire, the fire stops. Why is mercuric oxide a compound? Mercuric oxide cannot be separated into its constituents, mercury and oxygen, by any physical method. On heating, mercuric oxide decomposes into mercury and oxygen gas. The properties of mercuric oxide are completely different from mercury and oxygen. Mercuric oxide is a solid. Mercury is a shiny liquid, while oxygen is a gas. Similarly, sodium chloride is a compound of sodium and chlorine. Sodium and chlorine are highly reactive and poisonous elements. But the compound sodium chloride formed has completely different properties from the constituent elements. It is neither reactive nor poisonous. We use it as table salt. Which is the smallest part of a compound whose properties are the same as that of the compound. The smallest part of a compound is a molecule. All the molecules of a compound are alike and have properties similar to that of the compound.